So this is just me solving for x by factorization. So we continue in our page. Remember to write down all of this, right? So factorize by grouping now. This would be x minus 3. I would take out the minus 2 to get x minus 3. And remember, this is equal to 0. What does that mean for me? My factors are x minus 3 and x minus 2. Remember, we did solving by factorization. What you need to do now, when solving by factorization, is to put each factor equal to 0.
Miss,
Yes.
which topic are you, Miss? Come just get the meeting link and join the class, Miss. Come phone over there.
It's logs. We're doing logs right now.
Repeat.
Logs.
Okay.
Okay. When solving by factorization, you have to put each factor equal to 0. So x minus 3, this is going to be equal to 0. But you can't just neglect this x minus 2. It is also a factor. So what does that mean? In this case, in this particular question, there isn't just one value of x. X is going to have 2 values. So x minus 3 is equal to 0, and x minus 2 is also equal to 0. You can't just neglect that x minus 2, right? You'll lose marks. What I do now, I just solve for x. Therefore, x is going to be equal to 3. Therefore, x has to be equal to 2. What does that mean? My answer is x is equal to 3 and x is equal to 2. Everybody good with that?
Yes, Miss.
Okay. Let's continue these questions. Where's my name? Wait, anybody was still writing now? Anybody was still writing now?
No, Miss.
Okay. Cool. Let's hold on, don't write down the year again. Let me see what question is here. If this is what we're doing. Okay, this is right, next. So this is 2016 number, oh gosh, all that is 1. Okay, all that is 1. So it's number 1C, part 2. And this one is only 2 marks. The other one was 4 marks. Part 2, 2016. This is, gosh, that's a C, and it's 2 marks. So just do this one for me. I'll give you 5 minutes, and then I'll go through it. Okay, this is the equation that they gave me. So the minute you see a log equation, 2 things are supposed to pop up in your head. I have 2 rules when it comes to solving log equations, and I need to decide which rule I need to apply here. I'm not referring to the laws of logs, I'm referring to the 2 rules when solving log equations. And we said that those 2 rules are, the first one, if I'm given log form, which is this, the base A is equal to n, then I can write it in exponential form. N is equal to x. Or if this rule doesn't apply, well, yeah, I apply this rule or apply this rule. It depends on what question you're given, right? So log of n to the base A is equal to log of m to the base A. And we said if this is the case, if we're given this, then n is equal to m. So what you need to do, you look at your equation and you determine which rule am I going to use. However, just like the other question, none of these rules apply here. How come? Because I have 2 logs on one side of the equation and then 1 log on the other side of the equation. And I also have a 2 in front here. If you look at your 2 rules, do you see anything in front of the log?
No, Miss.
Exactly. So that's how you know you need to fix something, because you do not see a number in front of any of these logs, right? So you know then and there that you need to simplify using your laws of logs. Also, just like the other example, I have 2 logs on one side and then 1 log on the other side. If you look at your 2 rules, none of these rules talk about 2 logs being on one side and then 1 log being on the other side. No, you see the log form to exponential form, or you see log on one side, log on the other side, then n is equal to m. We have 2 logs and then 1 log. So that's how you would know, okay, I need to simplify using my laws of logs. If I look at this, right? So I did the laws of logs last yeah. If you need to look at that, Google Classroom. Okay, I have a law that says log, let me go mouse, log of n to the base a plus log of m to the base a is going to give me log of n multiplied by m also to the base a. And you need to notice the bases are the same. Okay, so I know that law. How do I apply it to my question now? That's what you should be asking yourself, right? Well, I see this. So I can apply this law right here. According to my law, one thing I need to mention, notice you don't see any base down here. So the base is a. Notice for this question, they didn't give you any. What you need to do for CSEC level is you need to assume that the base of this, well, these logs is 10. I have a note on that, right? Whenever you see log alone, you don't see any base, you need to assume that it's base 10. I need you to remember that, right? Assume it's base 10. I have a note on that, so I'll show you that after. Right now, just know whenever you see log by itself without a base, assume that the base is base 10. Okay, back to our thing. So I'm applying my rule. That's what I said I would do. Can anybody tell me if I apply this rule to this right here in the yellow box, what would I get? Log of what? Anybody? If you don't know, let me know. Huh? I'll just do it. Going once, going twice. Okay. Well, according to my rule, this right here, this expression is going to become log of x plus 1 multiplied by x minus 1. Remember, if I just see log by itself, I just assume it's to the base 10. So you could write the 10, you don't have to write the 10. It's assumed, like I said. And this is equal to, I would put back the 2 log of x plus 2, just for now. But remember, we said These two rules, they don't mention anything about a number being in front of my log. Hey, I have a number. I have a number 2. I have the number 2 in front of my log. So that's how I know, okay, I need to simplify this further so I can get it in this form or in this form, right? We also have another law that we could apply here to help us simplify it. What law is that? Well, that law states that n of log m to the base a is equal to log of m to the power of n to the base a. So how did they get that equation? All they did, you see this number here, they shifted it across and put it as the power of the number. That's all they did. They took this and shifted it across to a plane. That's what I did. Okay, now how do we apply this to our question? Well, I already established that this is log of x plus 1 x minus 1. And according to my rule that I just said, this 2, oh my gosh, no. This 2 is going to shift across and become a power. So what I end up with is log of x plus 2 squared. Now, I have log on both sides of my equation. And if I look at this rule says if I have log on either side of my equation with the same base, remember, must have the same base, then I could say n is equal to m. I have the same base here. Remember that we're assuming the base is 10. So both of them have the base 10, and I see log on both sides of the equation. What does that mean? I'm going to apply this rule right here. What does this rule say? N is going to be equal to m. What does that mean for me? That means that x plus 1 times x minus 1 is going to be equal to x plus 2 squared. You following so far? If you're not following, let me know.
Yes, Miss.
Okay. That's one person following. What's about the other two? Other one. You following? Silence. Okay. Remember, our goal is to solve for x, the value of x. So that's why we can't just stop here. We need to find out what x is. Did you reach this far in the question?
No,
Yes or
Miss,
no?
I didn't know what the 2 in front of the log means.
Well, that's a law. I have it on the PowerPoint, so I could show you. There are 6 laws that I showed them. And those are 6 laws that you would have to learn. And that's one of the laws. Okay, so we said now we're solving for x. We can't just stop right there. And from this point, it's just algebra, right? Expand the brackets, make something substitute the formula, solve. Yeah, basic algebra, right? So I would expand my brackets to get, let me use green. I would get x squared minus 1. When I expand these brackets, I'm going to get x squared minus 1. You can use your distributive law, or you can notice that these are difference of 2 squares. And this is going to be equal to x plus 2 squared. X plus 2 squared, when I expand those brackets, it's going to give me x squared plus 4x plus 4. If you don't understand how I did that, let me know, right? So I'll just show you how I expanded the bracket. Okay. Remember, we solving for x.
Miss, how did you arrive at x squared minus 1?
X squared minus 1. So you know about the distributive law?
Yes, Miss.
Okay. Hold on. Mouse screen trouble. Let me use.
Never mind,
Remember
Miss, I just saw it
story.
now.
Oh, okay. Cool. Remember, we're still trying to solve for x. So you see the x squared, and you might think, okay, quadratic. Miss said, once you see x squared, it's quadratic. But if I rearrange this, so say, remember I told you the minute you see an x squared, it's most likely going to be a quadratic. So you would be like, okay, let me rearrange my equation to get this equal to 0. Why are you doing that? Why are you putting it equal to 0? Because you know that's the quadratic form. So you would say, when you're rearranging this to make it equal to 0, you'd say x squared minus x squared.
Afternoon, miss. I just
It's okay. Plus 4x minus 1 minus 4 is equal to 0. Okay, I did what Miss said. She told me once I see x squared, I'm going to get a quadratic, put it equal to 0. Okay, nice. Let's move on. But if you look at this equation carefully,
Miss, wouldn't it be minus 4x?
minus, yes, thank you, minus 4x. Okay, right, thank you. So you see the x squared, you're like, okay, it's a quadratic. I need to bring it across to one side to get 0. But if you look at this equation carefully, x squared minus x squared, those are going to cancel. So this is no longer a quadratic. Why? Because a quadratic must have a term that's squared, right? Remember, when we were doing quadratics, we said the quadratic form is ax squared plus bx plus c is equal to 0. And we said that a could never be equal to 0, right? So if I cancel off these terms, because I said they would cancel, x squared minus x squared, they're going to cancel off. This is no longer a quadratic because I don't have a squared term, right? Remember, we did this when we were doing quadratics. So what am I left with? I'm left with minus 4x minus 1 minus 4, that's minus 5. And this is going to be equal to 0. Because this is no longer a quadratic, why is it no longer quadratic? Because I don't have the squared term, right? This is now in linear form. This is what we call linear form, right? Now I could just use algebra to solve for x. I would carry across the 5, so this would become minus 4x is equal to 5. And then I could say, okay, therefore x has to be equal to minus 5 and 4. And this right here would be my answer for this question. You understand?
Yes, Miss, I didn't know how to work it out with the 2, but I still tried it and I got the same answer.
Okay. You left the 2 there?
Yes, Miss. Miss, basically, I just said, Miss, I just times the x plus 2 times the x plus 2 and equate it.
X plus 2 and x plus 2. Oh, well, that's the same. Okay. Oh, 2 log of x plus 2 is the same as, okay, no, that's not. Yes, it does. 2 log of x plus 2 is the same as saying log of x plus 2 plus log of x plus 2. And then if you apply this rule, it would be the same as x plus 2. Log of x plus 2 times x plus 2. Okay, makes sense. It's the same thing though. You just didn't use the. Yeah. But that's correct though. Oh gosh, my mouse. Okay, next possible question. I don't think there are any more logs. No. You have to do those exponential equations. Oh. Okay, this is the log graph. We're not there yet. So you see, let me just show you this, huh? This would be a log graph, right? I know some teachers don't teach it because it rarely appears, but there is a possibility of it appearing. So I need to teach you it so that you don't go into your exam, see a log graph, and like, oh my gosh, what am I supposed to do? Because if you look at this, look at this question, right? We didn't reach there yet. But they want you to look at this table, look at this equation, no, not the table. They want you to look at this equation that they gave you and deduce. Using logs, you need to write this in its linear form. Some teachers don't teach that. Then you also have to sketch a graph. I mean, not even sketch, plot a graph using best fit line and all that, using the values that they gave you. And then you have to estimate constants. So imagine your teacher not going through that with you. You pull up in your exam, you're all confident, okay, I know everything. You get to, what is this even? I think this is one. Question oneself. Question 1, part C. You see a graph. You never seen that in your life. Start panicking. What's going to happen for the rest of the paper if that's just question 1? Not only do you lose what? How many marks is that? 3, 4, 7 marks. That's probably going to mess you up for the rest of the paper. So that's where I come in. If your teacher didn't teach you it, well, I will show it to you. Okay, we're not there yet. That was just my little TED talk. Let me see, 2018 and 2018. I think this one has a graph too. See, the graph came again in 2017 and 2018. So imagine those people who did not do the graphs. Headache. Okay, 2019. Oh, 29. Okay, let's do this one. This is paper 2, 2019. I think this is number one. So you realize the pattern. Logs usually come in question 1. I don't know, maybe it wouldn't be the same. Oh my gosh, no. Maybe it wouldn't be the same for your year, but for all the years so far, logs from question 1. So that's question 1, part C, paper 2, 2019. How much time I give you for that? 5 minutes again. 4 marks, yeah? It's 4 marks. If you could work this out, you get 4 marks already. So come on, you could do it. Just do this for me. 5 minutes, or maybe less. I don't know. And then I'll go through it with you.